Welcome to the Chapter 2 video. In this equation, you should recognize this as a quadratic in standard form. Recall that standard form includes the vertex of the parabola. So for this one, we see that the x-coordinate of the vertex, the opposite of 2, negative 2, and then the y-coordinate of the vertex is negative 1. So to make a parabola, we need at least 3 points, preferably 5. Now, I already have 1 point at negative 2, negative 1. So it makes sense to go up and down 1 for the x values and complete the table. So for negative 4, I'll plug negative 4 in for x and figure out f of x. And you see I get 11. Doing the same thing for the others, you'll get these 5 points on the table. So let's go ahead and plot the 5 points. Negative 4, 11. Negative 3, 2. Negative 2, negative 1. Negative 1, 2. And 0, 11. And we'll do our best to make kind of a U-shaped parabola there. Now, for a lot of graphs you draw, you'll notice that 11 probably won't be on your graph. Not a big deal if that's the case. Just go ahead and try to plot the parabola as best you can with those 3 points. Okay, on problem number 2, we're to find the maximum point on the graph. You should recognize this as a parabola opening downward. Okay, so here's our graph. Notice that we don't see the top of the parabola. Well, that's an easy fix. We just need to change our window. I'm going to change my y max to 20. So, to find that point, I can go to second calc. I'm going to choose maximum. I go to the left of the tip, push the arrow, or push the enter. To the right, push enter again. And it looks like my maximum is at 213. Now, alternatively, we could have recognized that this is a parabola where a is negative 3, b is 12, and c is 1. Well, we know the vertex occurs at negative b over 2a. So negative 12 over 2 times negative 3, and we get 2. Notice that the x-coordinate matches our x-coordinate over here. So then plugging 2 into our function, let's try that again. We get 13. So for number 3, we're going to determine the left and right-hand behavior of the following function. Now, what we're talking about is left hand is what's happening to f of x as x approaches negative infinity. And for right hand, we're looking for if, as x approaches infinity, what does f of x approach? So the answers for these will either be infinity or negative infinity. Now, the sole term that determines end behavior is the leading term of the polynomial, 3x to the 5th power. So we look at the degree, which is odd, and the coefficient, which is positive. This could have been any positive number. This could have been any odd exponent, and the end behavior would be the same. So if you have an odd degree, think of another odd degree function. Like, let's say we think of y equals x cubed. Y equals x cubed looks like kind of like a snake. And what is the end behavior of the x cubed graph? Well, as x approaches negative infinity this way, the graph approaches negative infinity. And then the right-hand behavior, as x goes on to infinity, sorry, mistake right there. So once again, as x approaches infinity, f of x approaches infinity. Now, if the degree was even, so this is not number 3. Let's say we had this function. We see that that's even, and that is negative. So what even function do we know the graph of? Well, we know y equals x squared. But this is negative, so y equals negative x squared would look something like that. So for this graph, as x approaches negative infinity, f of x approaches negative infinity. And as x approaches infinity, f of x approaches negative infinity. Okay, number 4, we're going to find a polynomial with 0, 0, 1, and negative 2. So if 0 is a 0, then x minus 0 would be a factor. If 1 is a 0, then x minus 1 would be a factor. If negative 2 is a 0, then x plus 2 is a 0. Now, normally I would not write x minus 0 here. Instead, I would just simply write x. So to find the polynomial function, I'll go ahead and need to multiply these out. So I'll multiply the first two. X times x is x squared minus x. Then I FOIL these out. X squared times x is x cubed plus 2x squared minus x squared minus 2x. Combining like terms, we get x cubed plus x squared minus 2x. Okay, next up we have a division problem. Now take a look at what we're dividing by. This is not a linear factor, so we cannot use synthetic division. We're going to need to use long division on this problem. Notice that I added the 0x squared because the x squared term was missing. Don't forget to do that, otherwise you may encounter some difficulties. So then, we start off with x squared and 3x to the 4th power. Now to find this number, what we're really doing is just dividing the 3x to the 4th by x squared. We divide and we get 3x squared. Once we've found that, we're going to go ahead and multiply the 3x squared to both x squared and 1. So 3x squared times x squared is 3x to the 4th. 3x squared times 1 is 3x squared. Now I'm not going to put 3x squared here because I have the x to the 3rd term. I'm going to write it below the 0x squared term. And then I'm going to subtract. So these cancel out as I wanted them to. I bring down the 2x cubed. This is going to be minus 3x squared. X squared and 2x cubed. I know that 2x cubed divided by x squared is 2x. So now multiply x squared plus 1 by 2x. 2x times x squared is 2x cubed. And 2x times 1 is 2x. Okay, so over here, notice that I don't have a term here, but I do have this minus 3x. So I'm going to go ahead and bring that down. And then I will subtract. Those cancel. I get negative 3x squared minus 5x. And then I'm going to need to bring down the 1. Negative 3x squared divided by x squared is negative 3. So I multiply x squared plus 1 by negative 3. And I get negative 3x squared minus 3. And my remainder is going to be negative 5x. And then 1 minus negative 3 is 4. So then I write my remainder over the divisor. And that would be my answer. Okay, number 6, find all the possible rational zeros of the function. Well, notice that all these have a common factor. Before we use the rational roots theorem, we need to make sure that we've fully factored it out. Now notice that 2 goes into 6, 32, and 70, and they all have 2 factors of x. So I can factor out 2x squared out of this function. So we know that 2x squared gives me 0 as one of my rational roots. But here I need to go ahead and find the factors of 35 over the factors of 3. So for 35, I have 1 plus or minus for all days, 5, 7, and 35. And for the bottom, I have 1 and 3. If you use 6 and 70 instead, you're going to get a lot more. A lot more. So let's go ahead and do this systematically. I'm going to take each number of the top divided by 1 first. So 1 divided by 1 is 1, so I get plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. Now using 3 as my bottom number, 1 and 3, I get plus or minus 1/3, plus or minus 5/3, plus or minus 7/3, and then plus or minus 35/3. Okay, well that will conclude part 1. I will put problems 7 through 11 on part 2.